going to see the AVL tree, binary search tree. Binary search tree is to be verified, so it's to be explained. So binary search tree in the sense it's a binary without search tree. Binary tree means maximum number of children for a node is 2, and binary search tree in the sense left child must be less than the value of the parent, right child must be greater than the value of the parent. So searching in the sense we need to find out whether an element is lesser than the parent or greater than the parent. If it is lesser means we need to follow the left child subtree, and the greater means we need to follow the right subtree. And the insertion in the sense based on the comparison in which place the current element to be inserted, that needs to be placed in the binary search tree. Deletion in the sense there are three kinds of cases. One is with the single child, with a double child, and the no child at all. So if no child in the sense we can delete that element. If it is a single child means we need to replace that single child with the parent, and if it has two child means it needs to be replaced with the in order successor. So this is the binary search tree. So adolescent, Welsky and Landis AVL tree in the sense self-balancing binary search tree. So the balancing parameter factor is height of left subtree minus height of right subtree between the -1 and the 0 1. So the complexity analysis is if you are searching element 1 means we have to traverse 5 4 1, that is log n, but therefore searching in the AVL tree has worst case complexity of O of log n. Insertion means for inserting element 12 it must be inserted at the right child of 9, therefore you need to traverse the elements 5 7 9. So the worst case is O of log n. In case of deletion also, if you are deleting the element 9 means we need to traversal 5 7 9, that is the worst case of log n. So balanced tree means the balancing factor, the height of left subtree and height of right subtree must be between -1 to 1. So h minus 1 and the h minus 2, then h is the whole thing. And the unbalanced tree means the value will be 2. Okay, the balancing factor if it exceeds -1 0 1, that is unbalanced tree. So here AVL tree in the sense we can see the node, all the nodes having the left subtree height minus right subtree, the balancing factor is between the -1 1 and 0. In order to make the self-balancing binary search tree, we are having 4 kinds of rotations: left left, right right, left right and right left. So consider RR rotation. RR rotation means if the newly inserted node, that is right child of the parent, means that it will makes that A element to be the balancing factor of 2. So we need to make B should be shifted as the parent and A is as a left child of that B. That is a balanced one. So this is the general form. So this is ABC in the sense we don't have the child of B and A, all those things. If you are having any kind of things means that K2 comes the parent K1 and the left child of K2 becomes the right child of K1. So LL rotation means similarly RR, here the left subtree of left child, the parent, the child is added. So B becomes the parent, C becomes the right child. This is the example. So in this case K1 becomes the parent, K2 is the right child, and Y is the right child of that left child of that K2. LR means combination of both L and R. So we need to make LR in the sense first the left rotation. B becomes A, B becomes the parent and A becomes a left child. After making LL we need to do the LL rotation, and this is a general form. So K2 becomes the first, initially K2 becomes the parent, K1 is the left child, that will be LL. Then K1 K2 becomes the parent, K1 is left child and K3 is the right child. RL in the sense both RR with the LL similarly. So we need to make B as the parent and C is the right child. After making that, that will become RR. So B as the parent, A will become the left child and C will become the right child. So this is the example. So initially K2 becomes the parent, and after that doing the RR, K2 is the parent of K3 and K1. So for insertion of 21, next 26 means which is greater than 21. So right child of the parent 21. The balancing factor is for the left subtree and right subtree for the 26 is 0, and for 21 left subtree is 0 minus right subtree is 1, so answer is minus 1. If you are inserting 30, that will comes under right child of 26. So 0 minus 1, the parent 21 will have the balancing factor because there is no left subtree, only the right subtree. So 0 minus 2 become minus 2. We need to make the RR rotation. So 26 as the parent, 21 as the left, 30 as the right. While inserting 9, 21 left subtree is 9, so there is no difference at all. While inserting 4 only, we are having the balancing factor of 21 is 2. We need to make the correction by doing the LL rotation, because we need to calculate each and every time while the insertion of any node happened in the tree, we need to decalculate the balancing factor. If the first node having the inappropriate balancing factor needs to be modified first, then it will automatically change the 26. So doing the RR rotation and the insertion of 14, 14 will make that 26 as the unbalanced one. So for that we need to make first right subtree of left subtree of right child. So RL rotation need to be done. Okay, after that insertion of 28, this will make 26, this will again or L rotation. Then insertion of 18 will doesn't make anything at all. By inserting 15, that will make the RL rotation. And then 10, 10 means this will also make the RL, but first we need to do the RL, in the sense 14 becomes the parent, and 10 now will become the parent. 14, 14 and 10, 15, 18 is downwardly shifted, and after that we are doing rotation for the 9 means 14 will become the parent and 10 now becomes the right subtree of 9. Insertion of 2, that will make the root node. So once again this will comes under LL rotation only. And for insertion 3 in the sense as will make LR rotation. So insert 7, that is LR rotation again. For the deletion we are having two cases, left side LL rotation, LR, and the LL rotation once again. So case 1, the deleting 40 will become deleting 40, so this will make the LL rotation. So 20 becomes parent, 30 is the right child, 10 is the left child. In this case deleting 40, in the sense this will make LR rotation. So here also 20 is the parent, 10 is right child, left child, 30 is the right child. Here deleting 40 means this will become the once again LL rotation. Okay, so 10 will become the root and 30, 20 will become the left subtree of 30. Deleting from the left subtree, so this is deleting from the right subtree, deleting from the left subtree. Here RR, RL and RR rotation. Similarly 10 is deleted means RR rotation. In the second case 10 will become the RL rotation. In the third case 10 is deleted means once again RR rotation. So this is the after the last case 25 will become the right subtree of 20. So this is the code. First we are defining the node, and the height is the height to be returned, and the height is one of the parameter in the node, and maximum means which one is maximum, that is returned. New node means based on the height is initialized with a 1. The new node is initially at the leaf node. And balance in the sense height of right left minus height of right, each and every node having the height as the parameter. So left rotate means we need to find out the height and the x, the height of x and the height of y. X is the node which is left of the given node y. Okay, and t2 is the right of the given node, because based on the subtree we need to make the condition. And the right rotate also similarly. Then while we are inserting, we need to check the balance factor in the if case. If it is exceed means based on the left key we are inserting means left rotate, otherwise right rotate. And then on the left right LR RL rotation and the LR rotation. This is the another one. And minimum value in the sense what is the current the left subtree, the last node of left subtree is the minimum value. While we are deleting, we need to identify the rotation at all. So whether the key is less than the parent or the greater than the parent, based on that the subtree is called. If it is only one child, find out the cases. So if it is not one child means replace it with the in order successor and find out the rotation for that. The balancing factor of the node is modified. Based on that the RR, RL, RR, LL rotation is called. Pre-order, root and left and right. So this is about AVL tree.